Right, first question, if something is moving at a constant speed, what do we know about our forces? We know that they are balanced. That is super important to know for the test. The acceleration would be 0. It is not accelerating. The net force would also be 0. I do not have a net force. Everything balances out. What force tells me the direction, the amount that it will actually accelerate? That's going to be your net force. So whatever direction your net force is, that's the way it's accelerating. Weight is just another word for Fg. Fg is mass times 9.8. What does acceleration mean? So acceleration is the rate that the velocity changes. So when we think about something moving to the right and speeding up, that has an acceleration to the right because I'm adding on to my velocity. If I'm moving to the right and I'm getting slower, I have an acceleration against me, a net force against me, which is why I'm slowing down. My velocity is decreasing then. Two ways to find F net is F net equals ma, or you can think about it as the total of all the forces. If you have acceleration, find it this way. If you have all the forces, find it this way. Total meaning add them up, except for if they're going in opposite directions, you would actually subtract. Do you need a net force to keep an object in motion? No. In fact, for constant velocity, you don't need a net force at all. You need a net force to accelerate, to change its velocity, but not to keep it moving at a constant velocity. Free body diagram, moving to the right at a constant speed. So if this was something on a surface, that would be Fg and Fn. Let's say I had an applied force, that would mean I would have an equal friction force. Constant speed means they have to be balanced. You also could have had it like this. If there was on a frictionless surface, that would also be constant velocity. Airplane coasting, so of course I have force of gravity. I would have some, I'm going to call it lift force. It's not a normal because it's not a surface, but some like engine holding it up. Let's say you have an applied force, then you would have some air resistance, or you can call it a drag force or friction force. If it's at constant velocity, it better all be balanced though. Book accelerating to the left, so if I have Fn and Fg, let's say I have an applied force, and that means my friction would be less. Or it's possible there's no friction, but you absolutely need a bigger force to the left. Block pushed on both sides, but accelerates left, so applied force and another applied force, but the left one is greater, Fn and Fg, and the up and down would be balanced because I'm only accelerating left, not up or down. Car is moving to the left, but getting slower, so I'm going to think of this as like my car, I put the brakes on, then the only force is the force of friction against me from my brakes. And if you're like, oh, it's moving to the left, okay, but my free body diagram doesn't tell me which way it's moving, it tells me which way it's accelerating. My acceleration is against my motion, so it'd be to the right. Object is falling, so of course, force of gravity. There would not be a normal force, there's no surface holding it up as it falls, so then my air resistance goes against motion, so it'd be upwards, and I'm assuming my gravity is greater than my air resistance, so it'd still accelerate down. Alright, here, unbalanced forces, I have a net force to the right, which means I have an acceleration to the right. Here, it's unbalanced, so I have an acceleration down. Here, everything is at balance, which means it is at rest, or it's at a constant velocity. I do not know which one. It could be at rest, or it could be moving at a constant velocity. Up, down, left, right, I have no idea. I just know it's not accelerating. Let's look. So find the missing friction force. So friction is mu Fn, and I was given mu. So I'm just going to plug in 0.35. That means I need to know my normal force first. It didn't give me an explanation of what's happening. Let's assume it's on a surface. It's not falling down. So then my gravity would be equal to my normal force. That means my force of friction would be 14 newtons. So that goes right here. Now I can find, because I have all my forces, I can find my net force. I would subtract those two because they're in opposite directions. That means my net force would be 6 newtons to the right. I need to find my mass before I can find my acceleration because I'm going to plug into F net equals ma. The only thing that would give me my mass is this force of gravity. We know that the force of gravity is mass times 9.8. So if my force of gravity is 40, I can just divide over and get my mass. You get your mass is 4.08. And then lastly, to find acceleration, that's net force equals ma. F net we already said was 6. Mass is 4.08. Now I'm going to divide the 4.08 over, and that gives me an acceleration of 1.47, and it's going to be to the right because my net force is to the right. My bigger force is to the right. Next here is saying what force is needed to establish equilibrium, so I want them to be equal. Right now I've got 11 and 6, so they are not equal right now. I would need to add an extra force in this direction to balance out, and I would need that extra force to be a force of 5, because now with the 5, now I've got 11 this way and 11 this way, which is equilibrium. Here, 8 and 16 is 24, and I have 35, so again, not in equilibrium. In this case, I need to add in an extra force here, because I need more on this side to get to 35. I would need to add an 11 Newton force. So I would need 5 Newtons here and 11 Newtons here. And then once you have it, you can double check. Yeah, that's 35 and 35 equilibrium. 10 is different. It's asking for acceleration. So I know I'm going to be plugging into my F net equals ma. I know my mass. It's 4. I'm looking for A. So I need to know my net force before I can find A. So let's look. I've got 2 this way and 8 Newtons this way. So that means my net force is going to be 6 Newtons to the left. Plug in net force, divide the 4 over. That gives me an acceleration of 1.5 to the left. Here, again, trying to find acceleration, so I know I'm going to need F net, so let's find that first. This just becomes 250. This one becomes 110. These are in opposite directions, so I'm going to subtract. So that gives me a net force of 140. This one wins, which is to the right. And then now I can find acceleration with F net equals ma. 140 equals 25a. Divide the 25 over, and that gives me 5.6 meters per second squared to the right. What is the force required to make this crate accelerate at this acceleration? So now that I know the acceleration of the mass, I want to find what is the net force needed. So net force is ma. 10 times 1.5 gives me a net force of 15 newtons. It's accelerating to the right, so that means my net force needs to be to the right. So let's think about, if I have 3 this way, I would need even more than that to end up with 15 to the right. So if I have 18 right here, see how 18 with 3 against me would leave me with 15 in the correct direction, so that means 18. Now, if you're like, well, I thought we would subtract, and you have 12, okay, then double check. If you have 12 and you have 3 this way, that gives me a net force of 9, not 15, so that's how you know it's wrong. Similar, I have an acceleration, I have the mass, so F net is just 10 times 4, it is 40 newtons, and it's to the left. So I want to end up with a net force of 40 to the left. So let's think, I've got 50 and 20, so right now I've got 30 in this direction, so not enough to have the net force I need, so that means I need an additional force of 10 newtons, and then let's double check. That would be 60 this way, 20 this way. That would subtract to give me 40 to the left. So that's good. The answer is 10. A 225 kilogram crate pushed horizontally with a force of 800. So that's like my applied force. I've got the coefficient of friction, that is mu. I'm looking for acceleration, and of course I have the mass. If you have mass, you can find force of gravity. So I'm going to do the 225 times 9.8. That gives me a force of gravity of 2205, and because this is on the surface, right, it's going to have a normal force of 2205. This is my applied force. It doesn't tell me direction, so I'm just going to make it go to the right. It doesn't really matter because it didn't specify. And I gave you mu, which means you can find force of friction, which is mu Fn. Mu is 0.2. Fn you already found. That gives me a force of friction of 441. So I'm going to put that. Obviously, that is less than my applied force, and it always goes against the motion. Now I'm trying to find acceleration. We know to find acceleration, we need to have our net force. So I'm going to find acceleration like this. So first I need to find my net force. Here, these two balance out, so I'm not worried about these. These two do not balance out. They're going in opposite directions, so I'm going to subtract 800 minus 444. Gives me a net force of 359. A mass of 225 still, and times A. Now I can divide my 25 over, and that gives me an acceleration of 1.6, and the direction would be, well, I didn't really give direction. It would be whatever direction the applied force is. In my diagram, it's right, but I didn't really tell you it was right, so we'll leave off direction there. Museum curator pulls a 1470 Newton weight sculpture across the museum floor with an acceleration of 1.5. If the coefficient of sliding friction is this is my mu, this is my acceleration, this is my weight. It says newtons, which tells me it's a force. The weight is going to be the force of gravity, right? How much gravity is pulling it down is the weight. I'm trying to find a lot of things, so let's just draw our diagram. I have the force of gravity. I do not need to multiply by 9.8 to get it because I gave it to you. So I know my gravity and I know my Fn. I have mu, so let's go ahead and find force of friction. That gives me 837.9. I also gave you acceleration. So acceleration helps me find F net because I do MA, but I don't have mass right now, so I need to find mass first. I did give you Fg, and you know the relationship Fg equals mass times 9.8. So if I plug in Fg is 1470 to get mass, I'm just going to divide over, and that gives me a mass of 150. And then now I can do F net equals MA. 150 times acceleration of 1.5 gives me a net force of 75 newtons. I was not super specific here. I promise in the test I will give you directions. The net force here is in the direction of the applied force. So I want it to accelerate with the applied force. So that means my net force, my applied force has to be bigger. So I'm going to add on to it. So my applied force is 75 newtons greater than this one, which is why I accelerate with the applied force. So I add on, and that gives me 1062.9, which is my answer. If the forces are balanced, what is zero? So I do have velocity, right? It's constant. It doesn't mean I have no velocity, so that's not zero. Same with the speed. These are both constant. My acceleration would absolutely be zero because if you're at constant speed, you are not accelerating. Your displacement, if you're at a constant speed, you're still moving, right? So that's not going to be zero. It's just A. Applied force of 40 newtons to the right accelerates. I've got a mass, I've got an acceleration. This is my applied force, and I want to know the friction and the coefficient, friction force and the coefficient of friction. So let's start with our Fg. That'd be 5 times 9.8, which is 49. And then my Fn, this is on a surface, is also 49. Applied force to the right is 40 newtons. I gave you guys a net, or not a net force, I gave you mass and acceleration, which means I can find net force. So it's going to be 30 newtons to the right because the acceleration is to the right. So if I have an applied force of 40 and my net force is 30, that means I must have a friction force going against me of the magnitude of 10 newtons, because 40 minus 10 would give me a net force of 30 to the right. That's the first question. Now the coefficient of friction is my mu, so I'm going to plug into the equation. Mu, force of normal force is just 49. So then we're going to divide the 49 over, and that's going to give me a mu of 0.204. So those are my two answers. Mu does not have any units. Force, of course, does for newtons, as newtons. 500 kilogram car sits on the road. It requires this force to keep it moving. Constant velocities, as soon as you see this, think balance. Doesn't matter what the constant velocity is, it's balance forces. And I'm looking for the coefficient of friction. So I gave you mass. Let's find Fg. That would be 49. That's a really big weight. I guess cars are heavy. That makes sense. I know that I need this force to keep it moving. So I need that much of an applied force. And constant velocity tells me balance, so that means the friction force is 1470. And to find the coefficient of friction, that would just be mu Fn then. 1470 is my friction, Fn is the 4900, and then I'm going to divide over, and I'm going to get my mu is 0.3. What is the force of air resistance on a 0.5 kilogram object falling with this acceleration? So if you have mass, you can find the force of gravity. 0.5 times 9.8 is 4.9. If you have acceleration, you should be able to find net force. So here you get your net force is 4.25 newtons. And it's falling down with this acceleration, so that net force should be down. Now what I'm asking for is the force of air resistance. We know air resistance goes against the motion, so that's going to be pointing up. And I'm just going to draw it less because I know that it's still accelerating down. So F air is my unknown right here. Well, let's think about, if I have 4.9 down and this is my net force, well, the air resistance is just the difference between them. So I'm going to subtract, and that gives me 0.65 newtons. And then just double check, 4.9 minus this much up would leave me with this much down. So then I'm correct, that is my air resistance. I would not have a normal force here because, right, it's falling down, there's no surface holding it up, there's no horizontal, it's just falling down. It's just gravity pulling down and air resistance you can think of as like the friction force going against. Finding the missing forces, this is net force of 0, so it's balanced, so that's easy. Here, I have a net force left. Up and down should be balanced, but to the left, I've got 80 newtons. I only want to have a force of 60, so that means I have 20 going this way. Spaceship in space fires its engines to speed up, and then the engines are turned off. What happens after the engines are turned off? It continues to accelerate, it moves with constant speed, it moves with increasing speed, and then the speed decreases, or it just decreases in speed. So if you turn the engines off, you don't have a force anymore, right? So it's not going to accelerate. Same with the increasing speed, right? You have nothing that's making it increase speed anymore, so I'm going to cross these off. Most people are probably between these two. You're used to it. If I throw my, well, that didn't work. If I slide my thing across, right? As soon as I stop, it slows down to a stop. In outer space, I don't have friction, so that's not the case. As soon as I let go, it's just going to continue forever and ever at that constant speed. It needs a force to speed up, but it also needs a force to slow down. There's no air resistance or friction in outer space, so it would just continue. A force of 14 to the left is applied, so that's my applied force to the left, to a 2 kilogram, that's my mass block. If the block accelerates at 3 to the left, so that's my acceleration, so I can find F net. 2 times 3 to the left is 6 newtons to the left. What is the force of friction? So you probably found force of gravity also. I think it's 19.6. I don't think you actually did it here. Oh no, it is, because the label every force. Now this is my net force, right? So if I have 16 this way, my missing friction force, I want to only end up with 6, so that means I must have, I can do this, 8 against me? 14 minus 8, yeah, that would leave me with 6 to the left. So then that is my answer. This is my force of friction. Three kilogram object, that's my mass, accelerated vertically at this acceleration. What is the upward force? So if you draw your free body diagram, of course you have gravity, right? Gravity is going to be 3 times 9.8, which is 29.2. I've got an upward force, it's accelerating up, so I know my upward force is greater. And then I have mass and acceleration, so let's find my net force. That's going to be 8.4. And of course it's up because it's accelerated up. So if my gravity force is 29.2 down and this is my net force, that means this force must be this much greater than the gravity. It's overcoming by this amount. So I'm going to add it, and that gives me whatever this force is 37.8. And then just double check. That gives me a difference of 8.4 in the correct direction. So then my applied force must be that, how much I'm pulling up. Here, I have the acceleration. I'm looking for mass, so I'm going to use F net equals ma. Looking for mass, we know acceleration is 2. Net force would be 12 minus 2, 10. Divide over, that's a mass of 5 kilograms. Net force acting on a 2 kilogram box produces this acceleration. What acceleration for the new mass? So, nu m. What is my new acceleration, right? But I have the same net force. So why don't we just find this net force? 2 times 4. So I've got a net force of 8. If I do the exact same net force, but with my new acceleration, so F net equals my new mass, then what would my new acceleration be? 1. Net force of F acts on an object of F, object of M, and I have an acceleration of 4. If they're the same but on an object of 2m, you should say this would be less acceleration, right? Same force but on more mass. Would it have a slower acceleration or less acceleration? So specifically by a factor of 2, so this acceleration should be half as much, or 2. Last one is finding the mass, and I have acceleration and I have force. So I can use any point. You can use this one. I can use F equals ma. This one has a force, x-axis of 0.5, a mass, I don't know, and an acceleration of 2. If I divide over, that gives me 0.5 divided by 2 is 0.25. And if you're like, why did you use that point? Well, let's use another. It doesn't matter. If I use this one has a force of 1, looking for mass, and this one has an acceleration of 4. If I divide 1 over 4, again, I get mass is 0.25. So it wouldn't matter which point, because it's the same mass throughout.